Hi, and welcome to the introductory video for the Kelliher School Fab Lab. In this video, I will be explaining what a Fab Lab is and a little bit about how to use it. I won't get too technical in this video. There's probably two terms that you'll need to know that are somewhat technical. Those are vector and raster, but I'll get to those in just a little bit. First of all, I want to talk about where Fab Lab came from. Fab Lab was an idea that came from MIT, and Fab Lab stands for Fabrication Laboratory. Neil Gershenfeld came up with the idea of Fab Lab when he discovered that machines used in fabrication had become affordable to the point where small institutions, local governments, and schools could set up fabrication labs of their own to encourage art and design. Even some remote areas of the world with low resources have benefited from Fab Labs. Once a Fab Lab is set up, the materials used in fabrication can be extremely inexpensive, but the skills that have been gained through the process of fabrication are oftentimes invaluable.
In Ghana, we had set up one of these labs. We had designed a network sensor, and kids would show up and refuse to leave the lab. There was a girl who insisted we stay late at night, her first night in the lab, because she was going to make the sensor. So she insisted on fabbing the board, learning how to stuff it, learning how to program it. She didn't really know what she was doing or why she was doing it, but she knew she just had to do it. There's something electric about it. And this was late, 11 o'clock at night. And I think I was the only person surprised when what she built worked the first time. And I've shown this to engineers at big companies, and they say they can't do this. Any one thing she's doing, they can do better, but it's distributed over many people and many sites, and they can't do in an afternoon what this little girl in rural Ghana is doing.
My name is Valentina Kofi. I am 8 years old. I made a stacking board.
And again, that was just for the joy of it.
So basically, a Fab Lab is a collection of computer-controlled devices that will fabricate your models and artwork in nearly any kind of material. We've got plastics that are made with the 3D printer. We've got wood and cardboard, fabrics, and other materials that can be cut with a laser cutter. This piece here was a piece that was cut with the laser, but it was also burned into with a raster image. Now, a raster image is probably the most familiar kind of image that you encounter. It's an image that's made up of small squares or pixels. And if you zoom into it, all of a sudden you will see those pixels. But from far away, you can't notice that it's made up of these small pixels. A vector image is quite different. A vector image is essentially a mathematical curve or a mathematical line, like a logo. One example, one of the simplest examples, is the Nike logo. The Nike swoosh is a vector. That curve can be recalculated to be nearly any size. In theory, you could take a vector image and blow it up to the size of a football field, the size of the moon, and it would not lose any resolution. Essentially, a vector is a mathematical equation. With an x and y axis, you can grid nearly any curve, and you can use that curve to cut something out of cardboard. You could cut it out of wood. You could cut it out of acrylic, plastic. You can also cut fabric. Many different materials can be cut with the laser, but we do have to be careful. There are some that release toxic fumes, such as PVC and vinyl. Now, we also have a printer that can print on vinyl, and we have a vinyl cutter that can make stickers that can go as decals on cars, on water bottles, on nearly any surface that you'd like. The vinyl cutter doesn't just cut vinyl, it could also cut magnetic materials, so you could do flat magnets for your room. Vectors are perfect for cutting out very crisp lines. Raster images, on the other hand, are good for detail. You can get really nuanced images like the one you can see here, and you can put those on, you can print them on a printer, you can wood burn them, you can, as you can see, burn it out of cardboard as well. Now, the 3D printer is an additive process. this plastic was added and built up to make this image. We also have a mill which takes away material. It's a subtractive process, and it can do the same types of objects, STL files or OBJ files, and it can create 3D images by taking away material. The mill can work in aluminum, it can work in obviously wood or foam or a few other soft materials. Finally, I'd like to talk a little bit about our plans for how our Fab Lab will run. The MIT Fab Lab Charter encourages institutions that have Fab Labs to open them up as much as possible to the public and to different departments within the organization. And that is definitely our hope here, as cross-curricular activities and projects can really benefit everyone here at the school. So we've already had one cross-curricular project that we've been working on with Ms. Kupcho from FACS. She came in with a pattern from Alaska that she had found that was highly detailed that she wanted to cut out of fabric. She knew we had the laser, but she didn't realize that we could cut fabric with the laser. And so I did some research and found the perfect settings to cut her fabric. She did an amazing amount of work to prepare the fabric and then afterwards make a beautiful quilt with this fabric. And what's really exciting for me is that now I have the opportunity to have my kids design their own quilts, and they can be highly detailed and quickly laser cut. And then Ms. Kupcho can come and help them with the skills they need to sew the fabric onto the quilt. So a perfect cross-curricular opportunity that we didn't have until we had the Fab Lab. I'm looking forward to working with more departments as much as possible and integrating art and fabrication and industrial design and technology into as many different departments as possible. This is just the beginning. I cannot wait for all the ideas to start pouring in. Please have patience with us while we figure out how to get them done in the most efficient way that helps everybody. So let's get started and enrich our curriculums school-wide. I can't wait to help with this process.